Welcome to the Oro Loma Castro Valley Water Pollution Control Facility. Located on the east side of the San Francisco Bay, we clean wastewater from the communities of San Lorenzo, Ashland, Fairview, Cherryland, Castro Valley, and parts of San Leandro and Hayward. The Oro Loma Sanitary District was formed in 1911 when a group of 29 community leaders saw a need for a stormwater and sewer system to reduce flooding and preserve the health of the San Francisco Bay. Little did they know that treatment facilities like this would play a key role in increasing the human lifespan in the United States and developing countries throughout the world. In 1948, a more sophisticated plant was constructed, and 10 years later, the neighboring Castro Valley Sanitary District partnered with Oro Loma, and they renamed the plant. In 1968, a new plant was constructed, which met the standards of the 1973 Clean Water Act for 40 years before undergoing an upgrade again in 2006. Today, the treatment facility serves a population of 180,000 and averages a flow of 12 million gallons of wastewater each day. Let's take a look at how the wastewater gets here and how the treatment process works. The wastewater is transported through 270 miles of underground pipes that end up here at the foot of Grant Avenue in San Lorenzo. Crews clean the entire system approximately every 9 months, use a robotic camera to inspect all pipes every 2.5 years, and schedule needed repairs. The headworks starts the process with bar screens that remove large objects like wood, rocks, and other debris that could damage or clog the equipment further downstream. Wastewater then flows to the grit chamber, where grit, sand, and other dense particles settle to the bottom, are washed and removed. The wastewater then flows through the wet wells and is pumped upward by these influent pumps. Inside the pump, a motor and impeller are used to lift the wastewater to the treatment unit. As the impeller spins, incoming wastewater is thrust outward into the pump housing, and then the discharge pipe. From here, the remainder of the process flows by gravity, which saves energy and helps the district maintain some of the lowest service rates in the state of California. Primary sedimentation tanks remove about 70% of the solids. The solids settle, are collected, and sent to a digester for further treatment. Some solids float to the top and are skimmed from the surface using a mechanical skimmer. The primary treated water then flows to the aeration basins, where secondary treatment begins. These basins add oxygen to the water, which serves two purposes. First, it creates an oxygen-rich environment for microorganisms that feed on the suspended and dissolved material left in the water. They grow and attach to one another in loose structures called floc. And second, it supplies oxygen that the organic material uses as it decays. This is important because when the water is eventually released into the bay, it won't demand oxygen from the bay that the fish and other wildlife need to thrive. But before any water can be released, it goes through several more steps. This is the secondary clarification process. Wastewater from the aeration basins comes up through the center column and is slowed down in the flocculation well. The newly formed floc particles settle to the bottom of the clarifier and are removed from the tank by this collector arm that draws the sludge into holes spaced along the arm. The sludge is sent to the digesters, and the clarified effluent water flows out over these weirs at the outside edge of the clarifier. The final process here at the plant adds sodium hypochlorite, commonly known as bleach, to disinfect the water. Due to the extended length of the channels, only a minimum amount of sodium hypochlorite is necessary to disinfect the water before it's sent to the East Bay Dischargers Authority for dechlorination. Remember all that sludge that keeps getting removed through the primary and secondary processes? Well, it ends up here in these digesters where it stabilizes for 15 to 25 days. The byproducts are a stabilized sludge called biosolids and a renewable source of methane gas. The The biosolids are placed in a solar drying facility and then hauled away. The methane gas comes from the digestion process. In fact, 100 million cubic feet is produced each year. The gas travels a short distance to the cogeneration plant, which uses the gas to generate heat and electricity. Together, the cogeneration plant and a solar array located on the district property create enough electricity and heat to reduce our power and gas bill to nearly zero, making the plant self-sustaining. And the whole process, from beginning to end, is monitored and maintained by a team of committed operations and maintenance professionals. From bar screens, through primary and secondary treatment, to disinfection and energy generation, the Oro Loma Sanitary District is always looking for ways to provide the best possible service, maintain the infrastructure entrusted to us, and provide the best long-term value for the communities we serve, all the while helping to maintain water quality and health of the environment where we live. We are here to serve you. For more information, call us at 510-276-4700.